Welcome to this explainer. We are diving into something absolutely wild today. A massive legal and philosophical shift in how the European Union regulates the very food on our plates, and ultimately what you're going to see in the grocery store aisle. For decades, the rules around genetic modification have been incredibly rigid. But science? Well, science just forced a total paradigm shift. We're going to unpack exactly how the state is redefining what it actually means for a plant to be natural. So let's kick things off with the question that is at the literal center of this whole debate. How does the law actually define what is natural? For thousands of years, farmers have altered plants through conventional selection, crossbreeding, all of that. But as modern biotechnology evolved, those lines began to blur big time, and it basically forced lawmakers to decide exactly where human engineering ends and nature begins. To really get why this debate is blowing up right now, we have to look at the catalyst. Since 2001, the EU has governed genetically modified organisms under a super strict directive. But then came a total scientific revolution, specifically advanced gene editing techniques like CRISPR-Cas9. Unlike older tech, CRISPR lets scientists make incredibly precise, targeted changes to a plant's own DNA in a matter of months, instead of centuries. It was a real game changer, and it made the EU realize their decades-old laws were, quite frankly, just no longer fit for purpose. Here's our roadmap for today. We're going to break this dense topic into 5 digestible pieces. We'll hit the regulatory shift, the new 20-edit boundary, the enforcement dilemma, patents and seed sovereignty, and finally, the global trade collision. Okay, moving right into part 1, redefining natural. Let's see how this shift sets the foundation for the new rules. So, the central theme here is a huge philosophical move. We're going from regulating how a plant is made to what its final genetic makeup actually is. Under the old 2001 GMO directive, regulators were completely focused on the process, specifically if you were using recombinant foreign DNA. If you took DNA from a totally different species and jammed it into a plant, boom, that's a GMO. Think of it like pasting a completely new foreign chapter into a book. But new genomic techniques, or NGTs, they are completely different. They allow targeted changes to the plant's existing DNA. It's much more like just fixing a typo in the book's existing text. Because of this, the new EU rules shift to a product-focused approach. They're looking at the final genetic sequence, not the lab tools used to get there. All right, part 2, the 20-edit boundary. How do lawmakers actually draw the line in the sand between a conventional plant and a genetically modified organism? Well, they came up with a really strict 2-tiered system to separate simple nature-mimicking edits from complex modifications. The lighter regime is called NGT1. To get into this category, a plant variety can have a maximum of 20 genetic modifications. And specifically, they have to be modifications that could have occurred naturally or through traditional breeding. If a plant checks those boxes, it goes through a simple verification process, and legally, it's treated as equivalent to a conventional plant. No massive GMO risk assessment, and crucially for consumers, no mandatory GMO labeling on the food. But on the flip side, you have NGT2. These are plants with more complex or extensive edits, and those stay firmly locked under the strict 2001 GMO rules, meaning full risk assessments, strict authorizations, and yes, mandatory consumer labeling. But hold on, because there are some hard limits here. The European Parliament made sure that certain controversial traits are strictly locked out of that lighter NGT1 category. Even if a plant perfectly meets the 20-edit rule, if it's been engineered to tolerate herbicides, or if it produces known insecticidal substances, it instantly gets bumped into the stricter NGT2 category to cover ecological concerns. Also, and this is a really vital takeaway, whether a plant is NGT1 or NGT2, neither can be used in certified organic farming. Because in the EU, even a nature-mimicking typo is just too high-tech for the organic label. Which brings us to part 3, the enforcement dilemma. Honestly, if we can't test for it, how on earth do we regulate it? Enter the European Network of GMO Laboratories, or the ENGL. This is the scientific body actually tasked with market control. Their whole job is to test food and feed entering the EU to catch any unauthorized GMOs. For decades, they've done this using PCR tests, kind of like the genetic tests we use in healthcare, to hunt down that foreign DNA inserted into traditional GMOs. But this is where we hit a wall. Because NGT1 edits intentionally mimic natural mutations. Often we're talking about a single-letter change in the plant's own DNA. There is absolutely no foreign DNA to detect. The INGL put out a major report and essentially warned regulators that without prior information from the developer about exactly what sequence was altered, it is highly improbable for enforcement labs to detect these unauthorized products. The watchdogs are, for all intents and purposes, flying blind. So this creates a massive legal headache known as the court-proof problem. Imagine authorities actually managed to detect a suspicious single nucleotide variation in a crop shipment, proving in a court of law that this microscopic DNA sequence came from deliberate laboratory genome editing rather than just a random spontaneous natural mutation. It's pretty much technically impossible. You literally cannot tell the difference between a lab-made typo and a natural typo, meaning regulators can't enforce what they can't prove. Moving on to Part 4, Patents and Seed Sovereignty. Let's look at the intense political compromise between massive biotech companies and everyday farmers. Who actually owns the building blocks of our food? It's a fiercely contested issue. Under this new agreement, NGTs do remain patentable, which is there to incentivize biotech companies to keep investing in research. But there is a major catch. Traits or sequences that already occur in nature, or things produced by standard biological means, those cannot be patented. Plus, the European Parliament fought incredibly hard to insert safeguards against extreme market concentration. The absolute biggest victory here is for the farmers. It ensures they retain their fundamental right to save and replant their seeds without the constant fear of aggressive patent infringement lawsuits. To keep everything above board, lawmakers set up some strict, step-by-step transparency measures. First, whenever companies apply to register an NGT1 plant, they have to submit comprehensive info on all their existing or pending patents. Second, all that data gets dumped into a public database. This means organic and GM3 farmers can just log on and easily check the records. And third, the Commission is setting up an EU code of conduct to guarantee fair and reasonable licensing conditions, so smaller breeders and farmers don't get completely priced out of the market. All right, final section, Part 5, the global trade collision. Let's zoom out to the geopolitical stage and see how this all stacks up internationally. We are seeing a really stark divergence in international standards here. Look at the EU with its strict two-tiered system. Now look right across the channel at England with their Precision Breeding Act of 2023. England went a totally different route, a binary system. An organism is either precision bred or it's a traditional GMO. If it's precision bred, no mandatory food labeling required at all. Plus, the EU lets individual member states opt out of cultivating NG2 plants, while England's framework has zero internal opt-outs. We are literally watching two completely different regulatory paths for the exact same science. And you better believe this matters for global supply chains. When neighboring countries, or even massive agricultural exporters like the US and Argentina, where this stuff is largely unregulated, have totally different definitions of what is natural, it creates immense geopolitical friction. A crop could be considered perfectly natural and legal in one country, but the second it crosses an invisible border, it instantly becomes an illegal, unapproved GMO. This kind of divergence threatens to cause massive trade disruptions and accidental illegal imports all over the world. So, the future of our food system. Bringing all these threads together, it's wild to see how a single microscopic edit to a plant's DNA cascades outward, affecting everything from laboratory detection limits to massive global trade deals. The EU is really attempting a delicate balancing act here, trying to foster climate-resilient agriculture while keeping a tight grip on consumer safety and transparency. Which leaves us with a pretty massive question to chew on. We are entering an era where scientists can mimic the exact mutations of natural evolution, making changes so incredibly precise that no laboratory on Earth can prove a human hand was even involved. As science permanently blurs the line between human engineering and nature, can our global laws and borders ever truly keep up? It's a profound question about the future of agriculture and the food sitting on our plates right now. Thank you so much for joining me for this explainer. I hope this helped clear up some of the incredible complexities of our rapidly evolving food system.